day everyone! Welcome to another episode of Quick Math Tutorial. Today, we are going to learn about two events that are mutually exclusive and not mutually exclusive. For mutually exclusive, if two events A and B are mutually exclusive, then the probability that either A or B occurs is the sum of their probabilities. In symbols, we have the probability of A or B, which is equal to the probability of A plus the probability of B. Or it can be represented by a Venn diagram. As we can see, the event A and the event B, they do not intersect. Therefore, we can say that the two events do not have a common elements or similarities. So, if the two events are mutually exclusive, we can use this formula. We will just add the probability of A and the probability of B. And for not mutually exclusive, if two events A and B are not mutually exclusive, then the probability that either A or B occurs is the sum of their probabilities decreased by the probability of both occurring. Or in symbols, we have probability of A or B, which is equal to the probability of A plus probability of B minus probability of A and B. Or it can be represented by a Venn diagram. As we can see, the two events intersect. Therefore, we can say that they have a common elements or they have similarities. So, if the two events are not mutually exclusive, we can use this formula. We will just add probability of A plus probability of B minus the probability of A and B. For our first example, let's have a bowl contains 15 chips numbered 1 to 15. If a chip is drawn randomly from the bowl, what is the probability that it is, first, a number 5 or a number divisible by 3, B, a number that is even or divisible by 4? So let's first solve for letter A. For our solution, since our event here is getting 5 or a number divisible by 3, hence the possible outcome in getting 5 is 5. Or for our second event, which is getting a number divisible by 3 or a number that can be divided by 3, so the possible outcomes are 3, 6, 9, 12, and 15. So the event in getting 5, this will be our event A. And the event in getting a number divisible by 3, this will be our event B. For our next step, let's identify if these two events are mutually exclusive or not mutually exclusive. So to answer that, we will just look at the event A and the event B. As we can see, they do not have a common element. So therefore, we can say that the two events are mutually exclusive. So since it is mutually exclusive, we can use the formula, the probability of A or B, which is equal to the probability of A plus probability of B, equals, for the probability of A, we have 1 because we just have one element in event A, over 15 because there are 15 chips in the bowl, plus the probability of B, we have 5 over 15. 5 because we have 5 elements in the event B. We have 3, 6, 9, 12, 15, or 1, 2, 3, 4, 5. So we have 5 elements. over 15. 15 again because we have 15 chips in the bowl. So to add this, we have 1 plus 5 is 6 over, copy the denominator, we have 15. Since these two fractions have the same denominator, or in lowest term, we will just divide both sides by 3, or 6 divided by 3, which is equal to 2, 15 divided by 3, which is equal to 5. Therefore, the probability in getting a number 5 or a number divisible by 3 is 2 over 5. And for our letter B, we will find the probability in getting an even number or a number divisible by 4. So for our solution, let's first list all the possible outcomes of the two events. So for our first event, we have an even number. So the possible outcomes are 2, 4, 6, 8, 10, 12, 14. Or for our second event, we have a number divisible by 4, or a number can be divided by 4. So we have 4, 8, 12. And we can note that this first event, this will be our event A, and the second, this will be our event B. For our next step, let's identify if these two events are mutually exclusive and not mutually exclusive. So to answer that, we will just look at the elements of A and the elements of B. And as we can see, they have a common elements, which are 4, 8, and 12. Therefore, these two events are not mutually exclusive because they have a common elements, namely 4, 8, and 12. So this will be our A and B. Thus, we can use the formula for not mutually exclusive, which is the probability of A or B, which is equal to probability of A plus probability of B minus probability of A and B equals, the probability of A is 7 over 15. 7 because there are 7 elements in the event A. We have 1, 2, 3, 4, 5, 6, 7. Over 15 because, again, we have 15 chips in the bowl. Plus, probability of B, we have 3 over 15. 3 because we have 3 elements in event B. We have 1, 2, 3. So we have here. Minus the probability of A and B. So we will look at the elements that are common in A and B. So we have here. So we have 3 elements. We have 1, 2, 3. So we will have 3 over 15. So to sum it up, we have 7 plus 3, which is equal to 10, minus 3, which is equal to 7 over 15. Therefore, the probability in getting an even number or a number divisible by 4 is 7 over 15. For our second example, we have Mark puts 44 marbles in a box, in which 14 are red, 12 are blue, and 18 are yellow. If Mark picks one marble at random, what is the probability that he selects a red marble or a yellow marble? First, we will list what are given in this problem. So we have 14 red marbles, 12 for the blue marbles, 18 for the yellow marbles, and 44 for a total number of marbles. and we are asked to find the probability of selecting red marble or a yellow marble. So for our next step, we will identify if these two events are mutually exclusive or not mutually exclusive. To answer that, we will just look at the given. And as we can see, red marbles is different with blue marbles, and blue marbles is different with yellow marbles. Thus, we can say that these two events are mutually exclusive. So we can use the formula, the probability of A or B, which is equal to the probability of A plus the probability of B. So our event A here is getting red, and our event B here is getting yellow, which is equal to the probability of red plus the probability of yellow. Next, the probability of red, we have 14 here over 44. 14 because there are 14 red marbles, and 44 because 44 is the total number of marbles. Plus, the probability of yellow, we have 18 over 44. 18 because we have 18 yellow marbles. So by adding these two, we have 14 plus 18, we have 32 over 44. Or in lowest term, we will divide both sides by 4. 32 divided by 4 is 8. And 44 divided by 4 is 11. Therefore, the probability of selecting red marble or yellow marble is 8 over 11. And for our last example, we have, out of 3,200 households surveyed, 2,107 had a dog, 803 had a cat, and 290 had both a dog and a cat. What is the probability that a randomly selected household has a dog or a cat? So for our first step, we will list what are given in this problem. So we have 3,200 as a total, 2,107 had a dog, 803 had a cat, and 290 had both a cat and a dog. So we are asked to find the probability of selecting a dog or a cat. So for our next step, we will identify if these two events are mutually exclusive or not mutually exclusive. To answer that, we will just look at the given, and as we can see, there is a common between a dog and a cat. We have 290 had both a dog and a cat, so they have a common elements. Therefore, we can say that these two events are not mutually exclusive. So we can use the formula probability of A or B, which is equal to probability of A plus probability of B minus the probability of A and B. Or our event A here is getting a dog and our event B here is getting a cat. So we will have the probability of dog plus probability of cat minus the probability of dog and a cat, which is equal to the probability of getting a dog is 2,107 because there are 2,107 households had a dog over 3,200 because that is our total, plus the probability of getting a cat is 803 over 3,200. 803 because we have 803 households who had a cat, minus the probability of dog and cat. So since we have here 290 who had both a dog and a cat, so we have minus 290 over 3,200. So to sum it up, we have 2,620. We get this one from 2,107 plus 803 minus 290. So we have here. Or in lowest term, we divide both sides by 20. So 2,620 divided by 20, we have 131. And 3,200 divided by 20, we have 160. Therefore, the probability of selecting a dog or a cat is 131 over 160. And that ends our quick math tutorial. If you liked the video, please click on the like button. If you have questions, just leave a comment below. And to be notified on my new videos, don't forget to click on the subscribe button. Bye!
Tell me pretty lies, look me in the face. Tell me that you love me, even if it's fake.